Hello, Legacy Sabers, Marsh here. So today we're going to talk about graphing and writing equations of translated parabolas in focused Directrix form. Whew, I know, lots of words there. You're going to want to find that conics foldable that we've been filling in, and we're going to fill out two different tabs today. So first tab you're going to open is the Parabolas tab for me. Now, last time we met, remember, we talked about a parabola being a conic section in which any point on the parabola is equidistant. We had a focus and we had a directrix. We found axis of symmetry and all that fun jazz. Now, that was when they were at the origin. What if I decide to move away from the origin? So these equations were when we were at the origin. Now, if I move away, it's going to look something like that when I decide to start moving this guy. So keeping that in mind, we are going to now have a vertex that's not 0, 0. It is going to be the H and the K. So let's take a look at number 9, shall we? So first thing I'm going to do is I need to find my p-value. P-value is still the same value as last time, but the negative 16, remember that is your 4p. So I'm going to solve that. 4p equals negative 16. My p-value is negative 4. So technically my p-value is a distance, so we're going to do a positive 4, okay? Opens. The thing that negative right here notates is that it's going to be either left or down. Now remember, how to figure that out is we're going to take a look at who's squared. Well, in this case, the x is squared. So that means it's either going to be up or down. Since it's a negative p-value, we're going to go down when we open. We're going to wait on our focal width. Let's find our vertex now. So the x value, it's going to be the opposite of the sign you see. So negative 3 and negative 4. So I'm going to graph that. 1, 2, 3, 1, 2, 3, 4. Here's my vertex right there. Okay. I'm going to wait for the axis of symmetry till I get my graph. My focus then, I'm going to follow my instructions. I'm supposed to go 4 down to find my focus. So I'm going to go 1, 2, 3, 4. Whoops, sorry guys. My pen decided to go wonky on me there. Boop. So 1, 2, 3, 4. No, that's not right. 1, 2, 3. Yeah, it is. There we go. So right there's my focus. That ordered pair will be negative 3, negative 8, it looks like. Now the directrix is going to be the opposite way. So I'm going to go up 4. So 1, 2, 3, 4. So right here will be where my focus is. Or, excuse me, my directrix. Now, your directrix is always a line. And since this is cutting through the y-axis, it's going to be y equals and the number 0. Now, remember, focal width is the number that is sitting out front here. So my focal width, since it's a distance, it's a width, can't be negative, it's going to be 16. So that means around my focus, from the end of the parabola to the other side, it is 16 across, which means I got to go 8 to the left and 8 to the right. So I'm going to count 8. 1, 2, 3, 4, 5, 6, 7, 8. Notice I'm going around the focus because it's the focal width. 1, 2, 3, 4, 5, 6, 7. Oh, just a little off the graph. Then I can connect my vertex to those dots. Missed that one by a hair. There we go. Now, my axis of symmetry can cut this pie perfectly in half right there at x equals negative 3, because that's the x value I'm cutting through. My domain, now let's look to the left. Negative infinity for that, right? Because we're getting all of the negatives, and I'm also getting all of the positive x's, so negative infinity, infinity. And then the range, well, I have all the negatives, right, until negative 4. Looks like my stopper point right there. Okay. Let's take a look at number 10. Number 10, though, is kind of special. Notice how this is in front of the squared term. That can't be. Okay, can't have it in front of the square term. So I actually have to remove and move it to the other side. Well, dividing, right? I would divide by negative 1 over 28. Well, I don't want to divide by a fraction. Let's multiply by the reciprocal. So I'm going to multiply by negative 28 on both sides. So my equation that I'm actually solving is the following. Y squared equals negative 28 parenthesis x minus 1. Now I could distribute that negative 28 in, but then I would just have to undistribute it to get it into its standard form for focused directrix. We don't want to do that. Well, my p-value, again, guys, it's this value divided by 4, so 7. I'm not going to take the negative because the negative just tells me which way I'm opening. Well, the y squared, so that means it's either left or right. And then it's a negative, so that means I'm opening to the left on this graph. My focal width, ultimately, guys, remember it's this number. It'll be 28. Whew, that's going to be big. And then vertex. Well, my x value is 1. My y value is, well, 0, right? There's nothing there. So I'm going to go 1, 0. That's going to be where my vertex is. Okay. My axis is symmetry. Well, we'll wait with that. Focus. Now I got to follow my directions. Left, 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Right there. Sorry, guys. My pen decided to go a little wonk again. So that would be, what's the order pair? 1, 2, 3, 4, 5, 6. 6, 0. Directrix going to go the other way. 1, 2, 3, 4, 5, 6, 7. So that's this line right here. Okay. That would be x equals 8, I think, for that. And I gotta go 14 on both sides of that focus, which is like all the way up there and like all the way down there. So it's gonna be a really big parabola. Super large. There we go. We could have made it 2 for each line, but I like to go off-road, as one would say. Axis of symmetry, I could cut this guy perfectly in half. Write down the vertex and the focus, which would cross the y-axis. So y equals, and the value would be 0. My domain, well, I got all the negatives, so I am at negative infinity because we go forever on the left. But I do stop right here at 1, it looks like. And then my range, well, we go forever negative and forever positive. So negative infinity to infinity, it looks like, for my range. Now, let's talk about writing equations of parabolas. So go ahead and close the parabolas tab and go ahead and open my writing equations of parabolas and hyperbolas tab. And let's take a look at some equations. Ultimately, I need to first figure out, is it left, right, or up and down? And then I need to find the p-value, and then I need to find my vertex. So my p-value, remember that is how far your vertex is to your focus. Well, it definitely looks like it's only 1, right? So my p-value is 1. Let's find where my vertex is. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 4. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. 3, 4. Yes. So I have 6, 4 for my vertex. And since this guy is up and down, that means the x is going to be who's squared. So I'm going to start plugging in my equation. So x minus 6 squared equals, that's 4 times my p. So 4 times 1 is 4. And then y minus 4 for my answer. So as long as you get your vertex and as long as you have your p-value, easily can write the equation. Let's try one more of the kinds of graphs. Again, let's find our p. The p is, remember, difference between focus and directrix. So 1, 2, 3, 4. 1, 2, oh. It looks like our line's a little off. We're going to have to back that line up. Sorry, guys. I just realized that. That's an issue there. That Directrix should be backed up a little bit. Okay, so scribble that guy out and draw yourself a new Directrix. So 1, 2, 3, 1, 2, 3, 4. So P is 4. Vertex, he looks like he's at -1, 1, 2. So -1, 2 for my vertex. Now, this guy is left and right, and he's opening to the right. So that means my y's got to come first. So y minus 2 squared equals 4 times my p-value, so 16, and then x plus 1 for my value. Now, I just thought, you know what? 23. This should be a -4, shouldn't it? I just thought of that. Look at that, guys. That is an upside down. That is pointing down parabola. He needs to be a negative. Sorry, guys. Almost missed that. Marsha's doing terrible on this video here. Now, let's try actually writing an equation given some information. So no graph anymore. I like, however, to do a little sketch so I know what it's doing. So 4, 3, right there, that's my vertex. My focus is 4, -2. So it looks like this parabola is doing one of these jobs, right? So it's pointing down. So I need to find the p-value, which is this distance, right? So how far is 3 to -2? Well, it's 1, 2, 3, 4, 5. So my p-value is 5. I have the vertex. It is pointing down, so I am going to have a negative when I multiply. So I'm going to start writing my equation. It is down, so that means my x is going to be squared. So x minus 4 squared equals 4 times p, which would be 20, but it's a negative because it's pointing down. That's how I'm notating it's going down. And then y minus 3. So I already used x in the equation. Let's try 26. So again, I'm going to do a little sketchy sketch. So -1, 7, 1, 2, 3, 4, 5, 6, 7 right there. And then my focus is at 2, 7. So it looks like he's doing one of these jobs. So he is a right-facing parabola. The p-value being 1, 2, 3. P is 3. He is facing right. So I have his direction, I have the p, and I also have my vertex. So I can start writing the equation. Since it's right, that means I have to use a y squared, correct? So I have to go y minus, and it needs to be the y. Be careful, guys. That's a very common error. So I'm going to use 7 squared equals. Then I got to go 4 times my p-value, which would be 12. Then I'm going to check. It's not left, so it's going to be definitely a positive p-value. And I'm going to go x plus 1 to finish it off. Now, what if I'm given the Directrix? Oh, no. It's all right. We got this, okay? So I'm going to do a quick little sketch. So 2 down 5. Probably is a line there. 5. Whoop, whoop, whoop. X equals 3. So that would be a line right here. So since that's Directrix, my parabola can't go towards the Directrix. So I go away. So it's going to be a left-facing parabola. My p-value, it looks like to be 1. Because remember, my p is also the distance from Directrix to vertex. So p equals 1. And I have the vertex. So we can immediately write the equation. Since it's left, though, remember, we're going to have a negative. So left, y has to be squared since it's facing left. So y plus 5, because that's the y value of my vertex, equals 4 times my p, which would be 4. Tack a negative on to notate it's going left. And then x minus 2. for the final answer. Number 28. I'm going to ask you guys to do that one on your own. We will do that problem together when we come back in class, so that way you guys can ask me a couple questions and just see how you did too. Just see, be like, hey, I'll see if I actually know what I'm doing on this information. But until then, I will see you later, Sabers.